Saxon Algebra 1, Lesson 2. In this lesson, we will review some geometry, angles, polygons, triangles, and quadrilaterals. Lines and angles. If two lines cross each other, we say the lines intersect. The place where the lines cross is called the point of intersection. Two lines in the same plane either intersect or do not intersect. If two lines are in the same plane and they do not intersect, we say that they are parallel lines. The perpendicular distance between two parallel lines is everywhere the same, much as in railroad tracks. If two lines make square corners at the point of intersection, we say that the lines are perpendicular. The angles made by perpendicular lines are called right angles, and we usually draw a little square at the point of intersection to indicate that all four angles formed are right angles. If a right angle is divided into 90 parts, we say that each part has a measure of 1 degree. So a right angle has a measure of 90 degrees. Two right angles form a straight angle. So a straight angle measures 180 degrees. An angle smaller than a right angle is called an acute angle, and an angle greater than a right angle but less than a straight angle is called an obtuse angle. Angle measurement in degrees was invented about 4,500 years ago by the ancient Babylonians. They divided a circle into 360 parts and called each part a degree. The first quarter of a circle contains 90 degrees, the next quarter another 90, and so on. The Babylonians used the number 360 because it is close to the number of days in a year, and also because it can be divided evenly in a number of different ways. These people split the year into 12 months, and each month contained 30 days. 12 times 30 is 360. You might wonder why they didn't notice something wrong, since a year really has 365 days. Well, they spent 5 days each year celebrating winter solstice, so those days didn't count. We also get 24 hours in a day and 60 minutes in an hour from the Babylonians. Anyhow, a degree is 1/360th of a circle, and 90 degrees is a right angle, since this cuts a quarter of a circle. A polygon is a special kind of geometric figure. The word polygon is formed from the Greek roots poly, which means more than one or many, and gonon, which means angle. So a polygon literally means more than one angle. Modern authors define polygons as simple, closed, flat geometric figures whose sides are line segments. A polygon is made of line segments joined at their endpoints. The segments are called sides, and the endpoints are called vertices. A vertex, therefore, is a corner or common endpoint of two sides. Here are some figures which are not polygons. This one's not a polygon because two of the sides are crossing each other. You can't have that. It has to be simple. This one's not a polygon because it's got a curved side. This one's not a polygon because it's not closed. All the sides have to be connected. And another one that's not a polygon because the sides are curved. Now let's look at some examples of polygons. One of the most common polygons is a triangle. The color doesn't matter. triangle has 3 sides and 3 vertices. Quadrilateral has 4 sides and 4 vertices. Pentagon has 5 sides and 5 vertices. And a hexagon has 6 sides and 6 vertices. Heptagon, 7 sides, 7 vertices. Octagon, 8 sides and 8 vertices. Nonagon, 9 sides and 9 vertices. And a decagon, which has 10 sides and 10 vertices. You're learning to count in Greek. If all of the sides of a polygon have the same length, the polygon is called an equilateral polygon. If all the angles of a polygon have the same measure, the polygon is called an equiangular polygon. Polygons in which all sides have the same length and all angles have the same measure are called regular polygons. We use tick marks to denote sides whose lengths are equal and angles whose measures are equal. These are some examples of polygons that are regular. Regular triangle, equilateral triangle, equiangular triangle. A square, that's a regular quadrilateral. All the sides are the same length and all the angles are 90 degrees. A pentagon, regular pentagon. And a regular hexagon. One way to classify polygons is whether they are concave or convex. A concave polygon has a cave in it, an indentation. A very precise way to determine whether a polygon is concave or not is to find out if there are 2 points inside the polygon that can be connected by a segment that goes outside of the polygon. If that can happen, it's a concave polygon. On the other hand, in a convex polygon, no matter what 2 points you choose inside of it, if you connect them with a segment, the segment remains entirely within the polygon. The polygon with the fewest number of sides is the triangle. Triangles have 3 sides and 3 angles. The sum of the measures of the 3 angles in any triangle is 180 degrees. Triangles can be classified according to the measures of their angles. This is a right triangle. An acute triangle, all the angles are less than 90. An obtuse triangle, one angle is bigger than 90. Or an equiangular triangle. Or they can be classified by their sides. An isosceles triangle has 2 congruent sides, 2 equal sides. An equilateral triangle has 3 equal sides. That's also equiangular. And a scalene triangle, none of the sides are equal. The lengths of the sides of a triangle and the measures of the angles opposite these sides are related. In an isosceles triangle, the angles opposite sides of equal lengths have equal measures. This works the other way around too. The sides opposite angles of equal measures have equal lengths. Remember that an isosceles triangle is a triangle that has at least two sides of equal length. The angles opposite these sides have equal measures. All three sides in an equilateral triangle have the same length. Since the angles opposite these sides have equal measures, an equilateral triangle is also an equiangular triangle. All three angles in an equiangular triangle have equal measures. Since the sides opposite these angles have equal lengths, an equiangular triangle is also an equilateral triangle. In a scalene triangle, none of the sides are equal, so no two angles have equal measures. Sample problem number 1. Find x. The triangle has two given angles, and we're to find the third angle. Just remember that the angles of a triangle add up to 180 degrees. Since 130 and 30 add to 160, that leaves an extra 20 for x. In other words, 20 plus 30 plus 130 is 180, so x is 20. Sample problem number 2. Find x and y. This time we're given only one angle in the triangle, and we have to find the other two. Observe that two of the sides are marked, and that means that these two sides have equal length. So this is an isosceles triangle, and we can use the idea that the angles opposite the equal length sides have equal measures. Therefore, x must be 50 degrees. And once we know x, we can find y because the angles add to 180. Since 50 and 50 is 100, that leaves 80 for y. Sample problem number 3. Find x and y. This is very much like the last one, except the side lengths are marked. So we have two equal sides. Therefore, the angles opposite these sides are equal. In other words, x and y are the same angle. Since the sum of the measures of the angles add up to 180, x and y have to add up to 70. Therefore, x and y are both 35. Last but not least, we consider some special quadrilaterals. First, the parallelogram. Opposite sides are equal in length. Notice that the tick marks are not all the same. The single tick marks indicate that those two sides have the same length, and the double tick marks indicate those two sides have the same length. The rectangle is a bit more familiar. It's like a parallelogram, but it also contains right angles. Opposite sides have the same length. A trapezoid, two pairs of sides are parallel, but the other sides are not, so no sides have the same length. A rhombus is a special parallelogram in which all four sides have the same length. It's like a square that's been tilted. The square is a rhombus with a right angle. All sides, again, have the same length. That's all for this lesson. Be sure to do the homework, problem set 2, on pages 8 and 9 of your textbook. Do all 30 problems, please.